Good morning everyone. Today, we are going to discuss the fascinating world of resistors. We will be discussing how they are connected in both series and parallel, and how they obey the laws of Ohm. We will also explore how these resistors can be used in various electronics. Let's get started. Let us begin our journey through the system of resistors. This slide will discuss the system of resistors and its components, including an introduction to resistors of series and parallel, along with derivations and diagrams. We will also look at the application of resistors, which is important in many areas of engineering and technology. Resistors are widely used in electrical gadgets to regulate and control the current. The behavior of resistors in series and parallel connections can be understood by applying Ohm's law. Connecting resistors in series will increase the total resistance, while connecting resistors in parallel will decrease the total resistance. This allows for more control over current and potential difference across the resistors. I will discuss resistors in series circuits. These are sometimes referred to as current-coupled or daisy-chain coupled. All components in a series connection carry the same current because there is only one path for the current to flow. To calculate the total resistance in a series circuit, the formula Rs equals R1 plus R2 plus R3 plus Rn is used. Resistors in series circuits are significant in controlling the flow of current in an electronic or electrical system. Resistors are essential components of electrical circuits and, as we have seen, when combined in series, they obey Ohm's law with the equation V equals IR. Furthermore, the total resistance of the combination, R_S, is equal to the sum of the individual resistances, meaning R_S equals R_1 plus R_2 plus R_3. Usually, the combined resistance is greater than the individual resistance. In a series resistor circuit, three resistors with resistances R1, R2, and R3 are joined together in one continuous path for the current to flow. The total resistance of the circuit is equal to the sum of the individual resistances, with each resistor adding its own resistance to the overall circuit. The slide showcases a system of resistors. In a parallel circuit, two or more components are connected in such a way that the potential difference across their ends is consistent. According to Kirchhoff's current law, the total current is the sum of the individual currents. This is a fundamental concept in electricity, which governs how components are connected in circuits. The diagram shows three resistors in parallel. The individual resistances of the three resistors are added together to equal the total resistance of the circuit. This configuration makes it easy to control the current flow in the circuit. We are discussing resistors and how they can be joined in parallel. Ohm's law states that current is inversely proportional to resistance. When resistors are in parallel, the equivalent resistance of the group is equal to the sum of the reciprocals of the individual resistances. This leads to a formula for the equivalent resistance of the resistors in parallel. In conclusion, when resistors are in parallel, the equivalent resistance of the group is equal to the sum of the reciprocals of the individual resistances. Resistors have numerous uses in our daily lives, ranging from heating elements in irons, toasters, heaters, and hairdryers that transform voltage into heat, to automotive LED lights clusters that necessitate specific resistor solutions. Resistors are critical. Aluminum-clad wire-wound resistors offer high power dissolution in cramped spaces and can be directly heat-sink mounted with the aid of a thermal compound for optimal performance. Appreciate your attention.